Hi guys, and welcome back. Today we're going to have a look at how to convert to 2's complement form. But before we do look at the examples, I have two examples in this video that I'm going to explain to you. We're first going to have a look at what is 2's complement and how we do convert to 2's complement form. First, you need to take the binary number which you have, and you need to convert all of the zeros to ones and all of the ones to zeros. So in this case, we're going to have that the binary number will look like this: 0, 1, 0, 0, 1, 1, and 0, which means that number is now converted to its ones complement form. Right, but remember we need to convert to 2's complement, which means we will add a 1. So then it will be 0 plus a 1 is 1. That will be 1, 1, 0, 0, 1, and 0, which means that number now is in my 2's complement form. Right, so stay tuned for this video. As I've said, I'll be doing two examples, and if you like this video, please subscribe to my channel for more of these interesting videos. Now let's have a look at this example. In the example, they say use 2's complement to subtract 4 from 11. So if you have watched the first video on 1's complement, you can see I'm using the same values as I've used in the 1's complement calculations. So the first thing that you do again is we write down the decimal values which we have, which is 11 minus 4, and we get the answer. What is the decimal answer in the decimal subtraction, normal subtraction? The second thing that you will do is you will now convert these decimal numbers to its binary equivalents, as I've done here. Alright, you can also use your code system which you have here by putting in the decimal value into the code system and see what is the binary number. So here you can see that 11 is, I'm going to need an 8, I'm going to need a 2, and I will need a 1, which will give me 11 in binary. The others will be zeros. If we take 4, I'm going to need the 4 of the binary number system, and the rest will be 0. So there I have my binary values. The next thing that you will be doing is you will take the second value, which is 4 in binary, and you will get the 1's complement for that specific binary number. And the 1's complement for 0, 1, 0, 0 is 1, 0, 1, 1. And that will be in its 1's complement form. The next thing that you will be doing is you will be now taking the 1's complement number and add a 1. The reason why you're adding a 1 is because you want to get the 1's complement number to its 2's complement. And if we do that, it is 1 plus 1 is 0 with a carry of 1. 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1, and 1 plus 0 is 1. And then that will be the 2's complement for that specific number. Next thing that you will be doing is you will take the first value, which is 11, its binary equivalent. You will take that and you will add the 2's complement number to that specific binary value. And that will be 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1 is 1, and 1 plus 1 is 0 with a carry of 1. What we do in this case when we have a carry is we simply ignore the carry. Right, so there you can see that my answer is 0, 1, 1, 1 to the base of 2, which is 7 when we convert to decimal. And there you can see, you can check your answer. There you have it. 7 in decimal is 0, 1, 1, 1 in binary. Right, so let's go to my next example. In example number 2, we have again 26 minus 20, the same values that we have in the 1's complement example. So the first thing again, write down your values. 20 minus 26 is 6, actually minus 6, but in this case we're just going to write 6. What I want you to see here again, as for the 1's complement as well, is that we're not going to have a carry now. Right, so the first thing that you do is convert these decimal numbers to its binary equivalent by using the code. And if we put 20 into the code system, we're going to use 16, we're going to use 4, and the rest will be zeros. For 26, it will be 16, we will use 8, and we will use 2, which will give us 26. Right. So the first thing that you do then, or the next thing that you will be doing, is take the binary equivalent for 26 and get the ones complement for that specific binary number. And the ones complement for 11010 will be 00101, and that will be in its ones complement form. Now remember, you need to take the ones complement of that number and convert it to twos complement. By doing that, we will add a 1, and we will have 1 plus 1 is 0 with a carry of 1. 1 plus 0 is 1, 1 plus 0 is 1, 0 and a 0 is 0, 0 plus 0 is 0. So that will be the twos complement number, which we convert to then. The next thing we will be doing is we take the binary equivalent for 20, which is that value, and we will add the twos complement number to that specific binary value. Alright, so now we're going to have 0 plus a 0 is 0, 0 plus 1 is 1, 1 plus 1 is 0 with a carry of 1, 1 plus 0 is 1, and 1 plus 0 is 1. There we can see we don't have any carry, and that's why I've written down here, no carry. I must complement again. So when you need to complement again when working with twos complement, you first need to take that specific binary number to ones complement and then add a 1. And that's why you will see here, we take that value, which is this one now, 11010 will now be 001001, which is then in its ones complement form. Then I will add a 1 to take it to its twos complement form. So 1 plus 1 is 0 with a carry of 1, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 0 and 0 is 0, and that will be the binary number in its twos complement form. And here you can see that 00110 to the base of 2 is 6 in decimal. And you can check yourself, there we have 6 in decimal, and if we convert 6 in decimal to binary, we will have 00110. And that is my second example. I hope you enjoyed the video. Please subscribe to my channel, and I see you next time. Thanks for watching.